Welcome guys, this is 9.1 Solutions of Systems of Equations. So we're going to solve systems of equations and then we're going to construct linear functions given word problems. You're going to learn how to determine if an ordered pair is a solution to a system of equations. So a system of equations is two or more equations that share variables. So here's one equation and here's your second one. Okay, it should be lined up, but that's okay. So you have two different equations that both have x and y and they share the variables. So traditionally you have a solution and it is wherever you have an intersection when you graph it, right? So this is your solution. And the solution is at this point right here, right? So this is 1, this is 5. So your ordered pair is 1, 5. So your solution is the intersection at 1, 5. Okay, and that's given a graph. If you're not given a graph, let's say you're given two equations like this. So we're going to figure out, is 4, 2 a solution to the following system? So remember again, you have your x, y values given in there. So we're going to substitute our x and a y into both equations and then see if they come out to be true or not. Right, so first one. So we do y equals x minus 2. So let's list that out. Our x value is 4, our y is 2, right? So our y value is 2, so we put 2 there. X value is 4 minus 4, so we get 2 equals 2, so this is true, right? So true for the first one. The second equation, y equals 3x plus 4, and say if this is true, right? So y is 2 again, 3, your x is 4 plus 4, so we got 2 equals 3 times 4 is 12 plus 4, and that comes out to be 16, but that's not equal to 2, right? So this is not equal. So this one's false. So what does that mean? Right? So if one is false, that means this is not a solution, right? Because if both equations are true, it is a solution. If either one or both are false, then it's not a solution, right? So this one is not a solution, right? Your y equals 3x plus 4 is not true for your ordered pair 4, 2. Right, so when you substitute 4 into x, it doesn't come out to be 2, so that's wrong. So it is not true. It's not a solution. Okay, we go to the next one. Is negative 2, 8 a solution to the following system? So again, you're given your x and your y. And we're going to substitute that into both equations. So first one, and then second one. So we got 4. Our x is negative 2 plus our y, 2 times y, which is 8. And we're going to see that. Does that come out to be 8? Right, so we see. So 4 times negative 2, negative 8. 2 times 8, positive 16. Add those together, you do get 8, which is equal to 8. So this one is true. Second one, so your y value is 8, again, times equals 4 times negative 2 plus 16. And then 4 times negative 2 is negative 8 plus 16. That is positive 8, so that is true. So that is true. So both are true. So is it a solution? Yes. Negative 2, 8 is a solution. Okay, let's try the next one. Same thing again. Right? Write your two equations. Negative 5x plus 8y equals negative 14. And x minus 3y equals 7. So we're going to see if the left side is equal to the right side. Right? So negative 5. Our x value is negative 2 plus 8 times our y, negative 3. And we'll see if that comes out to be negative 14. Right? So this is positive 10. minus 24. This is negative 14 or negative 14. That is correct. That is correct. So this is true. See the second one. X value negative 2 minus 3 times your y, which is negative 3, equals 7. So let's see, does that come out to be 7? Right, so negative 2, negative 3 times negative 3, positive 9, that is 7. So that one is true. So that means yes. Negative 2, negative 3 is a solution. Okay, so given a point, so is it a solution? You substitute it into both equations, and they both have to be true in order for it to be a solution. Okay, let's do number 4, which is a word problem. Okay, Stefan's school is selling tickets to a choral performance. On the first day of ticket sales, the school sold 10 senior citizen tickets, 7 child tickets for a total of $124. The school took in $188 on the second day by selling 5 senior citizen tickets and 14 child tickets. Okay, Stefan thinks the price of 1 senior citizen ticket is $4. So is it $4? And 1 child is 12? Is he correct? Okay, let's set this up. So we're going to set up our categories. We have our senior citizen tickets, right? So senior citizen. I'll put seniors. Then we get child. And then we have money. So we're going to set up our system, right? So we have 10 seniors, so 10x, plus 7 child tickets, so 10y. So use x and y, and that turned out to be $124. Then if we look at the next one, so school took in $188 on the second day, right? So this is going to be $188. 5 seniors, so 5x, and 14 children. Right. So the first one we have 10 seniors, 7 children, total of $124. Second day, 5 seniors, 14 children, total of $188. That's why we have 2 equations for first day, second day. Then we're going to solve it. Right? We're going to see, is Stefan right? So Stefan is saying senior citizen is $4, child ticket is $12. So what they're saying is your x is at 412. Is that a solution? That's what it's asking you. All right, so is 412 a solution? And that's what you try to answer. So you just substitute, right? So substitute x and y into both equations. All right, here's your x, here's your y. And let's see if it comes out to be true. So first one, right, 10x plus 7y, does that equal 124? Question mark. So let's put that in there. 10, our x is 4, plus 7, our y is 12. We're going to see that comes out. So that's 40 plus 7 times 12, 84. Add those together, that is 124. That is correct. Right, 124. So this is true. First one's true. Okay, now the second one has to be true. Right, so 5x plus 14y equals 188. Is that true? 5. Again, our x is 4 plus 14. Our y is 12. So 5 times 4, 20. 14 times 12 is 168. Add those together, you get 188. So that is true also. Right, so this is true. right? So that means is 412 is a solution. So Stefan is correct. Okay, so we set up our equations. 10x plus 7y equals 124. 5 seniors plus 14 children, 188. And then we're going to see, is 412 correct? So you substitute 412 into each equation and see if they come out to be true or false. If both are true, then it is correct. It is a solution. If one of them is false, not a solution. Does not work. Okay, let's try number 5. Okay, a local amusement park is a popular field trip destination. So senior class, let's see, high school A, senior class at high school B both planned their trips there. So we got high school A, high school B. Senior class at high school A rented and filled 6 vans, 14 buses, 360 students. School B, 3 vans, 11 buses, 264 students. Each van and bus can carry the same amount of students. And your friend says, is there 11 students in each van and 20 in each bus? We're going to see if that's correct. Right, so let's set up what we have. So we have vans and buses, right? That's our 2 categories. So vans, buses. And then students. So vans, 6 vans, so 6x, and 14 buses, right? 14y. That equals 360 students. Then we go to our next one. 11 or 3 vans, 3x plus 11 buses, 11y, equals 264 students, right? Right, so 3 vans, 11 buses, 264 students. This one's 6 vans, 14 buses, 360 students. So we put it in our categories, and now we have a system of equations, right? And we're going to solve this. And the question is asked you, is 1120 a solution? Because your friend said there's 11 students in each van and 20 in each bus. So we're going to see, is that a solution or not? Okay, so we're going to do our 2 equations. So 6x plus 14y equals 360. Does that work? And then 3x plus 11y equals 264. Does that work? All right, so 6 times 11 plus 14, or y is 20, equals 360. So 6 times 11, 66. 14 times 20, 280. Add those 2 together, you get 346. That doesn't match, right? Does not equal to 360. So that is not true. So this is false. So automatically you know this is wrong already. It's going to be wrong. Right, so if one of them is false, you know this whole thing is false. So this is no, 1120 is not a solution. Right there. So your friend is wrong. If we want to do the next one, let's just see. 3 times 11 plus 11 times 20, 33 plus 220. Add those together, you get 253. That's also wrong. Right, so both of them are false. But if already one of them is false, you know it's false. Okay, and that's it. And then complete the rest of them. So word problem, set it up, and then see if it's a solution. That's it for these problems right here.